Hello, friends. I'm starting a new online course on topic advanced manufacturing process. So, in this topic, I will put several advanced machining process and their mechanism, how it works, material removal rate, and so I will also talk about discuss some workout examples. This course is intended for undergraduates, graduates, and other professionals who are really interesting to knowing about this machining process. In this lecture series 1, so first I will talk about introduction of advanced machining process. So in this outline will be the some introduction, then AMP classifications, and how it has been classified based on several energy source, material removal mechanism, material types, process environment, scale of operation. And then at the end I will talk about the overall summary of that all advanced machining processes. In machining, it's like a like a shaping materials by removing materials. That's the basic definition of the any machining process. So you want some desired shape or the particular materials, and you have to do that by removing materials. That is called machining. It's mostly used for the metals, plastic, ceramics, and composites. And there are two broad category of machining process. One, we call it traditional or conventional machining process, and other one is advanced or non-traditional machining process. In traditional machining, material being removed using the cutting tools. Generally, there are several tools for each machining types are available, and which have using those tools, we get desired shape, right? So there are some key process: turning, milling process, drilling, grinding, shawing, brushing. There are several other processes also there. So I'm just only talk about the few machining process. So characteristics of these machining process are direct tool workpiece contact. So it's like a contact type material removal. So tool will always be in contact with the workpiece, right, which is to be shaped. And then moderate to high precision. So since it is in contact, so there will be vibration. Because of those vibration, there will be always some, it is very difficult to achieve low precised finishing or cutting operation. These processing processes are widely used in manufacturing since I think 17th or 18th centuries. Schematic diagrams of turning process, spindle with the revolving workpiece, and tool is engaged with the workpiece, and then turning operation starts, right? Tool post, machining beds. Similarly for milling tools are there to workpiece in a desired shape. Again, drill bit is attached to the spindle, and using the feed, manual feed or automatic feed, workpiece is being drilled, right? And similarly for grinding, the grinding wheel is attached to the machine and on the head, and then you can see that using that grinding wheel, my workpiece getting grind. Advantage and limitations of traditional machining process. So since you can I told you that it is the most, these machining processes are the most widely used. This is because of cost effective for small and medium production, widely available equipment and skills, suitable for metals, plastic, and composites, and high reliability with CNC system. CNC, a computer numerical control process, can be configured with the CNC, and it is very widely used in several industries. Versatile for various part size. And also there for the machining process, like struggles with hard materials such as superalloy or composites like aluminum based superalloy, which is used for the in aeronautical in space. And since these machining process are contact type process, so that's why tool with wear and tear in this machining process, and slow for complex geometry. So if somebody wants to get complex geometry, so there are a lot of fixture and arrangement is to be done in this machining modification, and it generates waste in form of chips and coolant. In the contact type machining, there are a lot of heat generation occurs, and to protect the workpiece and tool integrity, so coolant is used. And these are limited for the micro scale, macro to micro scale features, right? Mostly like in micrometer. The advanced machining process, so these machining process are specialized technique used for the machining hard materials, precise components, and intricate shapes. Means it's like a very complex geometry can be achieved through the advanced machining process. Are typically non-traditional, utilizing unconventional method of material removal such as thermal, mechanical, or chemical energy. Processes are crucial in industry like aerospace, automotive, medical, and electronics, etc. Schematics of there are some advanced machining process: abrasive jet machine, machining, ultrasonic machining, and electrical discharge machining process. Here machining, you can see the abrasive get mixed in the mixing chamber using with gas, air, and it passes through the very high speed through the nozzle, and it directly impinges on the workpiece, and due to the hammering or the impact mechanism, material is getting removed from the workpiece. So yeah, you can see here tool is not directly in contact with the workpiece, right? Similarly, for ultrasonic, there are some ultrasonic wave vibration tool gets vibrated, and uh, through the nozzle there are a lot of abrasive slurry passed through, and the combined effect of tool vibration plus the high speed abrasive slurry workpiece get shaped. Of the advanced machining process are, it's like as I told earlier, like a machines hard and brittle materials like a ceramics, high precision down to 0.005 millimeter. Even some machines are like a frequently worked for the nano features, minimal and no tool wear, because right. So L, for example, LBM and ECM, ideal for intricate geometry, suitable for thin walled parts. Limitations like high equipment and operational cost, slower for some process like ADM. ADM is relatively slow as compared to ECM. Or chemical machining, material specific, like for example, EDM process only worked for the workpiece which is conductive in nature, because we have to supply electric power and to the tool as well as the workpiece. That is the fundamental of the idiom. And environmental concerns like chemicals and energy, like involved in these machining process, complex setup and skilled operators are needed. We compare with the traditional versus advanced machining process, then you can see like a mechanism. It's like a traditional mechanical cutting. In advanced machining process, it could be a thermal, electrical, chemical. Precision wise, it's like a moderate to high in case of traditional, while in advanced machining process, it's very high, much better than traditional machining process, I can say. Material, so usually metals and plastics are get machined through the traditional machining process, but in advanced machining process like a hard materials, some ceramics, titanium based alloy application, it's a general purpose used for traditional machining. And if you need micro or complex shapes or even nano features, then um advanced machining process is are always there. Come to the AMP classifications. So here I will discuss about the advanced machining process, classified under energy source, metal removal mechanism, material types, process environment, scale of operations. So under the classification based on energy source, it's like a mechanical energy based process. So you use under this process, it uses mechanical energy for material removal, right? Thermal energy based process, it uses heat energy for material removal. And chemical energy based process use chemical reactions. Combined energy process utilize more than one energy source to achieve material removals. Mechanical energy based process, under this energy based process, there are two most widely advanced machining machines are available, like AGM and USM. So AGM stands for abrasive jet machining, while USM stands for ultrasonic machining. So AGM, um, in this process, high speed abrasive particles are carried by gas or air to erode material. So there's another version is also available. We call it abrasive water jet machining. So instead of gas or air, abrasive particles are mixed with the water, and it passes through the high speed to erode the material. And ultrasonic machining in this machining process, it uses high frequency ultrasonic vibrations with abrasive slurry for precision machining. The schematics of these two processes, abrasive jet machining and ultrasonic machining. So what we said here, that figure depicts the same. Now come to the thermal energy based process. Here under this classification, there are four major advanced machinings are there. Laser beam machining, it uses laser beam to melt or vaporize the material. It means melting and vaporization will get removed. Electron beam machining, and this machining, it uses focused electron beam to melt or vaporize the material. Similarly, in case of plasma arc machining, it uses high temperature plasma to cut and melt materials. And in electro discharge machining process, it erodes the material through the electrical discharges between a tool and the workpiece. The dielectric solution, here in this process, tool and workpiece both are submerged in a dielectric solution, and then material removal occurs. Schematics diagram for laser beam machining, electron beam machining process, similarly for electron discharge machining, and here plasma arc machining. You can see in for example, in plasma arc, electrode, gas orifice, torch body, here like it's a nozzle, and it the mechanism generates the plasma. It develops a plasma arc near to the workpiece, and due to the high heat and melting zone occurs, and in that zone materials get removed under chemical energy based process. So in under this chemical energy based classification, so there are two machines are available: ECM and CHM. ESM stands for electrochemical machining, and CHM stands for chemical machining. In ECM, it uses electrochemical reactions to dissolve material, and generally Faraday laws of electrolysis follows in this machining. And in chemical machining process, it removes material using chemical agents to each etching process or dissolve part of the workpiece are there for electrochemical machining and chemical machining. So yeah, you can see the maskins are there, the portion we don't want to get remove, so that what we did, we put maskant on the that area in the workpiece, and then the workpiece is submerged in a chemical that we call it etchant, and due to some chemical reaction, material removal occurs. Classification, we call it combined energy process. Here what we in this process, what happens, actually we combined more than one energy, like a hybrid manufacturing. For example, it integrates 3D printing with traditional machining techniques. Laser assistant machining, it combines like a laser energy as well as the mechanical forces for enhanced machining, right? So I will discuss this machining process in a detail in church, right? So now classification based on material removal mechanism. So I told you like a material under this classification, material removal by vaporization. So under this one, it's laser beam machining, electron beam machining, and plasma arc machining. These in this machining process, materials get removed by vaporization. Then laser beam machining, both occurs, melting and vaporization. Well, by erosion. So abrasive jet machining, ultrasonic machining, again abrasive jet, water jet machining, right? Then material removed by chemical action, electrochemical machining and chemical machining. In electrochemical machining, material is removed by two things, like electric reaction between the cathode and anode that activates under the electrochemical solution. Based on material types. Here, let's say if you want to metals, then laser beam machine, ADM, plasma arc machining, because these machines will not work on other than metals, right? So for non-metals, ultrasonic machining, laser beam machining, abrasive jet machinings are there. For composites, theoretically it's like almost all equipments, like a water jet cutting, laser assisted machining, ultrasonic machining can be used. And for ceramics and glass, LBM, AGM, and USM can be used. Based on process environment, so there are three environment, we like a dry machining process, wet machining process, and hybrid machining process. So under the dry machining process, like a laser beam machining, abrasive jet machining, and ultrasonic machining, in those machines I told you, like here there are no coolant or any solutions are used. It's only like a, let's say for example, in case of laser beam machining, the laser light will come and directly come in contact with the workpiece, and in that the light where it will imping, so in that zone melting and vaporization will occur, and there is no uh, you know liquid or things are used. Right. So in a weight machining process like electrochemical and water jet or chemical, so here what workpiece is will be always in a weight condition. Right. Hybrid machining process like laser assisted machining. What I told you here, multiple machining process are hybridized to get better feature and better performance. We discuss more about hybrid machining process. So it is classified under two category, major category like assisted hybrid machining and combined hybrid machining. So under the assisted hybrid machining, there are several machining processes are available like a heat assisted, vibration assisted, magnetic field assisted, abrasive assisted, external electric field assisted, or media assisted. Combined hybrid machining, it is directly combining two process. In assisted, it means there is a one major machining process and it is being assisted by some other form of energy to for better performance. But in combined hybrid machining, like for example electric discharge grinding, so here what is happening, grinding machine process plus electric discharge machining process, both are combined with each other, and then some intrinsic features are generated in on the workpiece. Right. So some other process on under the classification of combined hybrid machining is there: electrochemical discharge, laser electrochemical, mechanico electrochemical, electrochemical grinding, etc. So classification based on scale of operation. So here micro feature, macro, micro, and nano. So macro machining process for larger scale operation with significant material removal like laser beam machining and plasma arc machining. These machines for high material removal rate as well as the, so that's why it is used for large scale operation, and it is for good for macro machining. But for micro machining process for small scale precision work like a micro ADM, micro laser beam machining, micro ADM, lot of machine, the advanced machining process has been modified for to get micro and as well as the nano features some on in case of some machines um, on the workpiece. Right. So overall summary of advanced machining process. So let's say laser beam machining best for precise cutting and engraving of hard materials. In electron beam machining suitable for very hard material and fine features. Electrochemical machining ideal for intricate shapes in conductive materials. Ultrasonic machining best for brittle materials like ceramic, glass, and composites. So process under the different classification and summarized here. So if you'll see mechanical energy based classification, AGM, USM, thermal, LBM, EBM, PM, uh, EDM, and chemical energy based like ECM, chemical machining, combined energy, LAM, hybrid manufacturing, material removal, vaporization, LBM, EBM, PM. So what I discussed in earlier slide, this is the summarized table. Advanced machining process are essential in manufacturing high precision component. The choice of process depends on factors such as material types, required precision, scale of operation, and energy source. And these advanced machining process enable manufacturers to meet the increasing demands for complex geometry and high performance materials. And there are a lot of research, ongoing research going on to cut down the cost as well as they enhance the performance to get micro or nano features. Advanced machining process are trying very hard, engineers and researchers are very trying hard to achieve those features using advanced machining process. So these are the two reference books you can follow. Advanced machining process is by Professor VK Jain, and he was my professor. He taught me like advanced machining process as well as the micro or nano manufacturing process when I was a student in IIT Kanpur. If you have any question or query about this machining process, or if you want some any modification or you have any suggestions, you are always welcome to write your queries or comments on in comment sections. So thank you for watching this video, and I will always I will post all the one by one, all I will prepare the slides and then I will make video for this advanced under the advanced manufacturing science. And I hope this course will help you to understand manufacturing science. Right. So you can subscribe to my YouTube channel. So right now I am putting this video under the Nirbhik Sanyogi channel, but later on uh, In future I have make a new channel for the this based channel. We call it Nirvigyan, and I will put video on that channel. Right, so I will ask you to, request you to subscribe my both channels, and you can like, share, or whatever. If you want to donate something, you can always donate through the YouTube. Thank you very much for watching this video. Thank you.